We all feel the gravitational attraction of the Earth on us. Even if we jump as high as we can, we are pulled back towards the ground every single time.
Ah, gravity, thou art a heartless bitch.
If you think that if we could jump much higher, we would manage to escape the gravitational pull of the Earth, you're right. This is related to the concept of escape velocity. The escape velocity is the minimum speed needed for a non-propelled object to escape from the gravitational influence of a larger body and reach an infinite distance from it with a final zero speed. Using Newtonian gravity and conservation of energy, we obtain a simple expression for the escape velocity. For example, the escape velocity from the Earth's surface is about 11 kilometers per second, or equivalently 40,000 kilometers per hour. Really fast! To launch spaceships from the Earth's surface, we need to take into account the Earth's rotation and its atmosphere. Even if we do not notice it, the surface of the Earth moves at a certain speed due to its rotation. This speed is used as part of the escape velocity of the rocket. As the surface velocity is maximal at the equator, it pays off to launch from as close to there as possible. Traveling at a hypersonic speed within the atmosphere will cause atmospheric friction, and that can even burn the flying object.
Houston, we have a problem.
This is one reason why rockets leaving Earth do not reach the escape velocity straight away when they launch. What they do is the following. They burn their propellant to steadily accelerate until out of the atmosphere. There, they can reach the escape velocity, which is now smaller due to them being further from the Earth, or even go into orbit for a while and then accelerate to escape the gravitational pull of the Earth. As we mentioned before, the speed needed to escape from the Earth's surface is about 11 kilometers per second, comparable to that of Venus, which is about 10 kilometers per second. In contrast, the escape velocity of the Moon is only 2.4 kilometers per second. And if you were standing on Mars' smaller moon Deimos, you could escape its gravitational pull by running at 20 kilometers per hour. In the case of Jupiter, the largest planet in our solar system, the escape velocity is of 60 kilometers per second. However, bear in mind that it is a ball of gas, so it has no solid surface to launch your rocket from. Moving on to stars, the escape velocity of our Sun is of 618 kilometers per second. Still, it certainly is too hot to set up a space center. The more massive and smaller an object, the larger the escape velocity from its surface. You may be wondering, but how large can the escape velocity get? Well, the largest physical speed is the speed of light. And that is also the escape velocity at the event horizon of a black hole. Inside of the black hole horizon, the escape velocity is actually larger than the speed of light. However, that speed is just not attainable, so you would not be able to escape the gravitational attraction of the black hole.
There is no escape.
Watch one of our videos to find out what would happen if you ever got trapped inside of a black hole horizon.
If you enjoyed the video, like and subscribe. And don't forget, you ask CENTRAnswers.